So in this problem, we're asked to find how large of a buoyant force will just submerge the block in a vat of oil with both densities of the oil and block of wood being known. The equation that we're going, well, let's, rather than thinking in terms of just equations, let's sort of draw the picture and seek to understand the problem. There's my block, there's the oil that it's in. When we talk about density, force, and this buoyant force stuff, think of it in terms of forces. And a lot of it can be traced back to stuff we've covered earlier. The buoyant force acts up, the weight acts downward on this thing. Now this object is pushed just underneath the surface of the water, and we need to figure out, well, how large a force, I guess will be required to make that happen. So the forces we have, it's not moving, it's in static equilibrium, I guess is what we're calling. So we have the buoyant force equal to the weight of the object. What things that we do know? We know the density of the wood is 0.85. That's the wood. The density of the oil is 0.95. We know if this thing is fully submerged underneath the water, then the volume of the water and the volume of the oil that are displaced, the volume of the wood and the volume of the oil that are respectively displaced are the same. And then if we use equations that we have been given, oops, there we go. Buoyant force equals the V oil minus, I guess that's density of the oil. Density of the oil minus the density of the water times the volume times G. This problem we just plug right into what we're given. So we know 0.95 minus 0.85. Now the volume of this wood is going to be length times width times height. Okay, so whatever those calculations, 15 times 14.7 times 4.7 times the acceleration of gravity when we go and do this. So in reducing things down, we know that this value here is 0.1 because we subtract those off. If you multiply those across, we get 1036.4, and this is 9.81. Now what I want to bring to your attention is that density is in units of grams and grams, and these are centimeters. When you multiply all those centimeters together, you're going to get centimeters cubed. If you notice, you're taking the difference in density times volume. Well, because the volume is multiplied by the density, the volume is going to be cubic centimeters, the density is going to be cubic centimeters. Those will cross off. Those go away. So you're going to be left with something, our result here will be in grams, and if we can just do some real quick mental math, that'll be 103.64 times 9.81. That is not going to be our final answer, because this 103.64 is just grams. We need to divide this value by 1,000 to convert the grams into kilograms. So if you sort of incorporate that division by 1,000 into the mix, your final answer for the buoyant force should come out to be 1.02 newtons as the force needed to submerge this object under the water.